And so it's now, I think, up to us who are not in that field of the AWSs and the GCPs to help people understand that they framed it that way intentionally. It's really like a marketing ploy almost. But you don't have to move to them. You can bring the cloud to you. The cloud is a philosophy. It's like, yes, automate things, make them easy for your developers to get a hold of resources trivially, give them APIs, give them all these things that allow them to very quickly have the resources that they need. This is very common in any of these automated systems, OpenStack, again, just being one of them, but OpenStack provides a foundation for many large companies. And now it's much more available for people to, smaller organizations to get a hold of.
This is Sovereign DBaaS Decoded, a podcast for IT leaders and implementers looking to reliably scale database ops while maintaining control of their data stack. In each episode, we join industry experts to discuss the what and why of sovereignty and how you can implement the sovereign DBaaS concept of your own using open source databases, deployment models, and tooling. Let's get started.
Hello, and welcome to another episode of Sovereign DBaaS Decoded, brought to you by Several Nines. I'm Vinay, co-founder and CEO of Several Nines. Our guest today is Todd Robinson. Hi, Todd. Todd is president and co-founder of InMotion and OpenMetal. So thanks for joining us today. So can you tell us a little bit about you and what you do?
Yeah, sure. And thank you, of course, for having me. And I'm excited to be on with Several Nines because we both are joint kind of customers, you could say, of each other's. I'm very excited about how Several Nines has helped out the OpenStack world with providing both inspiration, I guess you could say, for good database as a service, and of course, actually running database as a service for customers. So I'm excited to be here. And but my background actually, so I come from 20 some years in hosting, and at that time, we were always automating infrastructure and trying to automate it as best that we could. And so we actually created a company outside of that based upon the automation that we were using inside of InMotion, as you mentioned. And so, I'm kind of here now today talking about OpenMetal. And my views, I think you could say, are really been educated by the years in the hosting and then in the automated infrastructure, and thus coming in from OpenMetal.
Yeah. Okay. Great. So cloud, I mean, you've been in the business for, 2 decades. I don't know if you agree, but cloud, it's kind of thought of as a destination, right? Because we often think public cloud, we often think, hyperscalers, but does that still hold true today, right? 2024. So that's kind of what we want to discuss in this episode. How conceptions of cloud need to go beyond, right, narrow definitions based on location and, expand it to be thought of as an operating model, right, that can be applied across multiple infrastructure. That's the thing, right? How can we apply it across multiple environments, and how is open source helping to make that happen? So let's jump right in. Is it changing? Right, this kind of historical, idea that cloud has been thought of as, as a destination. Is it changing?
Yeah. So I think you're hitting it right on the head there, Vinay. And it is a historical reason that people are thinking of it as a destination. And cloud back in the day when the big mega clouds there were first coming out, they really had a superior process. They had a superior product, so they had great automation. And so it kind of came synonymous with like, oh, if I need to go to the cloud, I've got to move out into AWS, of course, is the original. And that has been pervasive, even though at very similar times, the cloud was being built, OpenStack as a great example, by some original founders, Rackspace and of course, the government, NASA. And but the hype as they're called today, hyperscalers, they had a great product, admittedly so. And so over the years, people said, oh, okay, I've got to move to the cloud to get this great automation. Well, of course, that's been a long time since that occurred. And cloud systems, cloud software, OpenStack, Cloud Stack, various systems like that have dramatically matured. And so these systems, they're available in a mature fashion today. And so now it's a lot of times educating people to go like, hey, look, you got to remember underneath any of those hyperscalers, it's all the open source stuff. I mean, it really honestly is. And many of them have obviously taken a lot of effort to hide that it's actually the open source systems that are underneath it that are providing their automation and providing this like great user experience. But in reality, it is the open source systems underneath. And so there's many providers that you can go to nowadays that can provide you very, very similar experiences, OpenMetal just being one of them. And so it's now, I think, up to us who are not in that field of the AWSs and the GCPs to help people understand that they framed it that way intentionally. It's really like a marketing ploy almost. But you don't have to move to them. You can bring the cloud to you. The cloud is a philosophy. It's like, yes, automate things, make them easy for your developers to get a hold of resources trivially, give them APIs, give them all these things that allow them to very quickly have the resources that they need. This is very common in any of these automated systems, OpenStack, again, just being one of them, but OpenStack provides a foundation for many large companies. And now it's much more available for people to, smaller organizations to get a hold of. So yeah, Vinay, I think I'm hitting on the spots that typically people do and say like, hey, it's a philosophy. You don't, and then you hear people say, well, I'm going to cloud repatriation. Well, cloud repatriation, you're not really going to leave the cloud because it's a philosophy. It's not a location. Absolutely, your systems teams, your engineering teams, your development teams, they should all have easily available automated infrastructure accessible to them. That's the cloud. It's not where you are, it's the philosophy that you're using.
Yeah. I mean, in a way, it feels a little bit, I don't know, strange that the hyperscalers kind of, they took the whole narrative, the whole cloud narrative. They own that whole narrative for so long. But I think, we can agree that, this notion of cloud as a destination is kind of changing. So we can agree to that. Now, why is that? I mean, I think, you did mention there are open source components. There's a lot of automation software available today that maybe wasn't available, 15 years ago. But today, I mean, is it a changing business environment where cost is being more maybe, scrutinized? Or are the risks like increased regulation in data privacy?
I think privacy, of course, and regulation, I think in particular too, sometimes in the United States, we're a little bit distant from that because we, I guess, are just less sensitive, partly because the hyperscalers are kind of born out of the United States. But if you were to go around the world, I think you're going to find a very different take on it. The European Union and its member states, they're really saying like, no, we take our privacy more seriously than those in the United States do. And they've created a lot of laws and moves and even funding for local organizations to help, kind of raise up their infrastructure providers and the skills and the companies literally coming from those regions. So I would say, yes, of course, that is some of it. And it's just different regions in the world putting down their foot and saying like, no, you're going to store our information here. Stop putting it over here in the United States. But then I would also say, I mean, cost is always a pain point. And I think the big clouds, the original narrative was very much like move to the cloud. You're going to have great agility and you're going to save money. Well, as it turned out, one of those was true. You had great agility and the public cloud for many things are wonderful. And we have customers that are public cloud providers that run on top of OpenMetal. And it's great for certain use cases. It's literally, it's one of the best things for like getting things really quickly up and running, doing your POCs, understanding how things are going to work. Public cloud's brilliant. And it does absolutely save money in those cases. But once you hit a tipping point, when you get to a scale where you're now paying for automation every single time you touch something, that becomes very, very expensive. And again, at scale, it's typically where now you're not getting the benefit of that additional scale that where normally your engineering costs drop dramatically, right? Like, oh, I built this thing and now I get to use it or sell it many, many times. I get the advantage of the big scale. Well, when you're on the public clouds, they get the advantage of your big scale. And I think it's now a lot of the CFOs are starting to get angry at the CTOs going like, how come this thing just keeps climbing? Can't we do something about this? I'm used to, as I get greater scale, I get greater efficiency. And in many cases, that's not the case with the big public clouds. And so I would say it's mostly the pain that is really causing this is that, as it turns out, the mega clouds narrative about cost savings, is not true once you hit a tipping point. And so that's, I think, what's really pulling people back to go like, wait a minute, I think I need to look at the new cloud deployment models. Once they've kind of realized like, no, I can move from the public clouds and still be cloud native. Now, what are these other cloud deployment models that are available to me? And then that's where people start down that path of like, okay, now I have to go and look and really understand how modern the systems are and the providers that are using those systems, and what are my options nowadays.
Right. So what do you make of the, you talked about cloud costing a lot. I guess 10, 15 years ago, right, there was a difference between what kind of hardware you could get then and what you could get now. But, there is a discrepancy now between the hardware costs, right, and the cost of cloud. I mean, I don't know, 10 years ago, maybe average servers could have an average of, 4 cores, 8 gigs of RAM. I mean, nowadays, the servers that you can buy, right, easily, 30 to 64 cores, hundreds of gigs of RAM, server and storage density means we can pack quite a lot of processing power, into smaller spaces, right? And in the last decade or so, the cost of solid state, right, has gone down by like 10x. So you're getting, effectively you're getting 10x more processing power for less, right? If you buy hardware. At the same time, if you look at the IaaS prices, they've kind of gone up over time. And that discrepancy, right, between the hardware cost and the IaaS, right, IaaS, that makes enterprise wonder if they should do, their own thing. I mean, can you talk a bit about that?
Yeah, there's always a couple things that I bring up when we're looking at those things. So absolutely, the hardware has dramatically improved. And from a cost standpoint, I would almost say from a hardware is in some ways stayed a relatively similar cost, but the size and the capabilities, like you said, the cores, we're even now looking at a 256 core Ampere now. It cores, literal cores, not threads, but actual cores, 200 out of one CPU. But adoption of that type of technology does require a pretty decent amount of engineering work. And so there is always going to be this, you have to be at a certain scale in order to get the benefits and realize the cost savings in that. Just negotiating, getting the right stuff, figuring out that it's going to work properly with KVM or your virtualization system. There is a certain level of complexity inside of that. And so adopting these new technologies, there is this cost. That's why I kind of typically go back to, there's always a tipping point for workloads, and it's a public cloud. There's definitely things that are good. And again, we're like a mixture company. We're on-demand private cloud or on-demand bare metal that people turn into essentially a public cloud of their own. So they're like, I'm going to have basically my own AWS when I come to OpenMetal. And so for us, we're very driven though, because we have essentially a fixed cost model. So we're trying to take that hardware, sell that hardware at the hardware level to a customer, include all the engineering that I'm talking about and having the cloud and having it be cloud native already on top of that. But our model is a fixed cost model. We want companies, when we believe that it's super important inside of our cloud field, to have this fixed cost option so that these larger organizations, once they hit that tipping point, they can go, oh, wait a minute, I can get a hold of a cloud native system at a much more predictable cost. For me, it is yes, the big cloud company. I'll pick on AWS just because it's an easy one. AWS provides a large portion, and in many cases, in some years, the only profit that Amazon has as an overall organization. And so partly the reason why the public cloud costs don't go down, because it's a cash cow for AWS, right? Or for Amazon. And Amazon actually as a business, they use that to fuel their competitive Amazon.com shop against other companies, which I still find bizarre when I see sometimes like these big retailers, they're like, we're super excited. We just went on AWS's cloud. And I'm like, they're taking your money and funding the Amazon shop with the profit margin in AWS. I'm like, wait a second, guys. Like, this is why I say, like, I get pretty fired up to say that there needs to be a a competitor like this, and we're not the only ones. Luckily there are other competitors like this that are coming up to say like, no, once you hit a certain scale, this is the right place to be. And honestly, stop buying from your competitor. That's never a good idea, right? Like this is one of those things where you're like, you probably should know better. And so, yeah, I think for me, I think I'm segueing a little bit. I don't know if I exactly answered your question. So, Vinay, please ask that again if I have gone off in left field on you here. But yeah, I would just say, yes, there's tons more power, tons more resources. AI is now in, you need to think about that. You need to understand what's going to happen there. But the same thing, that can get very, very expensive. You need to understand that there's a great time to be in the public cloud providers for it. But you also need to know that we as the private infrastructure people, we're also going after it. We've got a private AI cluster coming out shortly. We know that there needs to be a balance within the ecosystem for everybody to have the benefits of the cloud, but also at the reasonable price once you get that tipping point.
Yeah. Now, something a little bit more high level, I mean, if you look at the current economic environment, right, there's been increased inflation, high interest rates. I looked at the historical price, prices from the hyperscalers, and they've kind of gone up, slightly over the years, right? I think they were high like 12 years ago, and then it came down, and then it's been kind of flat, and then it's kind of gone up, slightly. Will we see sharp increases in cloud service prices, do you think?
That's an interesting. I don't know if I could look forward. This is one of the things that I would expect to happen. The three big ones here in the United States, right? Clearly they don't like actually collude or anything like that. But when you look at their pricing structure, it's very clear that they've just kind of said like, well, don't be too much different from that one or this one because they want those margins in the long run. I would think you're going to see what I think from the hyperscaler side, they're probably most concerned with the pressure on the egress, the money that they make on egress. And it's simply because, most, like a lot of competitors like us, egress is a very inexpensive thing nowadays. It has been actually inexpensive for a long time. And so for them, the margin is very, very large, but also they're used to it. But there's a lot of pressure. We put the pressure as much as we possibly can. We want people to go like, wait a minute, why am I paying this crazy number for egress when egress should be basically nothing? So my guess is that's the place that they're going to have to react. And so that you will see that egress pricing come down from them. But I don't think you're going to see it in the other techs, like AI stuff and things like that. I think you're going to see they're going to stick with their model and underline, of course, they're making their own things less and less expensive, and that's what's helping them with their margins. But that would be the only place I might, maybe 2 years from now, you might expect them to start to react to the market and start to push their egress pricing to be somewhat more competitive. I kind of hope they don't, honestly, because that's one of the things where people go, you know what, I'm out of here. I got to go to somebody that I have a reasonable egress cost from. That would be my guess. I don't have enough probably info to predict too much further than
and actually,
that. That's what I see.
There is the sort of the Data Act, the European Data Act, right? And since beginning of this year, I think I've seen Microsoft and Google remove egress costs when you're leaving them. When you're leaving them, then it's
Isn't that? But you have to fill out a form. You have to send in a form to get it. It's just but I'm with you, Vinay. Is that would be one indicator where they're clearly listening and the market is.
But I think the sort of EU Data Act kind of probably prompted that, right? Because they want to nurture competition, right? Reduce lock-in effects, between from a large provider and there's a lot of scrutiny there. So I think we have seen one small aspect, but it's not like somebody can just say, hey, I don't like the egress, I'll just move everything, and it's free for us to move the data out, right? Because it's still
this is honestly on our side. Sometimes we basically have to give credit to the customer that's incoming because we know they're going to have this problem on the way out. And so sometimes you just have to, but they know the deal. Like a company has always known, like there's going to always be a certain amount of vendor lock-in and move-out cost associated with it. And so usually you just got to talk to the company that's helping you out when they're trying to solve that. I mean, here's the thing, and I won't go too far into this one is, I mean, in the big cloud world, all the big clouds have cross connects with each other. That egress, in most cases, it's not even going onto the internet. It's like hopping down a couple switches and routers and going into the other location. It's not egress. They have cross connects with each other, and they don't pay, and they just take the money as it moves back and forth. So anyways, I hope I don't get yelled at for that one, because I think everybody I think knows that, but it's kind of one of those things that until you're like really faced with go, oh wow, really? They're charging me egress, but it's actually not going on the internet. It's just going into a cross connect in one of these meet me rooms. Yeah, it is. Sorry.
So now a cloud is not just hardware, right? I mean, you have the infrastructure automation tooling, right, which is available today that makes it feasible. Do you see the increasing cost discrepancy and the available tooling, right, making, let's say, repatriation more attractive? Now, I will take your point, right? You mentioned it's not really repatriation because it's from cloud to cloud, right? But let's say what I'm saying, what I mean by repatriation is moving it from a hyperscaler to somewhere else, right? So do you see that kind of discrepancy in the tooling making those cases more attractive? And actually, do you see an increase in your business in those type of cases?
Yeah, I think interesting is depending on the use cases of the customers, different providers like OpenStack. And actually, if you wouldn't mind, just because the people that I'd like to share this video with don't know as much about Several Nine. So if you don't mind, I'm going to ask you a question just to kind of help fill this in. But for example, in the OpenStack world, we don't have a strong database as a service, right? And there's a system called Trove that's kind of born out of the open source side of it. But expertise in database as a service is both the automation of creation of it and having the resources be in the right place, but you must also have really solid knowledge of the databases that you're automating. And so the OpenStack world actually doesn't have as strong a database as a service as some of these other providers. Now, given those other providers are typically just automating on top of a open source version, or they're now, like 100% Postgres compatible, even though it's been built a little bit differently. So if you wouldn't mind, maybe I'll kick that back to you, because I think you guys in particular are very important for the OpenStack world because of the work you do. But yeah, if you don't mind, run through that a little bit just so that reviewers of mine are familiar then with what you all are doing.
I mean, you can get database as a service, right, from AWS, Google Cloud. And the problem is when you move it to your OpenStack or even, to local location where you're using some other software, right, you don't have that. You don't get that kind of automation. So yes, you can do it yourself, right? You can do Ansible, write your own scripts. If you're in Kubernetes, some people are using these operators there. Although the operators, maybe they don't have the full kind of day two operations. They do a couple of things, but they don't help you do everything you need. And, in the previous podcast, we had a Kubernetes expert on this, as a guest. And, basically we found out that probably you'll have to fork some kind of operator out there and then just, build on it, right? And then when there are updates, you need to keep that going. So yeah, so what we do is, we help. You can take, our software and do DBaaS. You can do it in the hyperscalers. You can do it on your OpenStack. If you have barebone, you can do that here as well, right? On-prem traditional systems. So we're kind of an automation layer for database, which is agnostic of the actual underlying environment. Right, and it helps because the problem is if you are in, for example, AWS and you're stuck into Aurora, then you can't go, out of AWS and expect the same Aurora. It doesn't exist, right? Then you got to pick up some existing tools. So OpenStack has been a very good, it's very popular. It's been a very good, let's say, infrastructure play for us to have the database as a service on top of. and it gives you the same kind of database services that you can get from the hyperscalers.
Yeah, and so the familiarity with that. Would you speak to maybe some of the databases themselves for familiarity, and then the ones where you would say like, yeah, we do this great, and you're going to love this part of what we do with this database?
So we have, the common ones, traditional ones, MySQL, MariaDB, Postgres. We have the NoSQL ones, MongoDB, Redis, Elastic. And we also actually do, SQL Server, Microsoft SQL Server, right? And then there's a bunch of others.
Nice.
Like, Postgres has some extensions, like Timescale is a popular one for time series. PG Vector, right, for AI kind of applications.
Okay.
So we do those as well. And the other thing is, we can also see some of the providers changing their licenses. Like MongoDB changed their license, right? And it's not open source; it's SSPL. Redis has also just changed their license. Elasticsearch also has a different license. But as an enterprise, you can actually use our software to automate these databases inside your own data centers or inside your own, kind of clouds, private clouds, right? So from that perspective, even though it's not open source, it's also available. You as an enterprise, you can still use it for internal use. So that's another advantage of having your own automation, because I think what MongoDB, Redis, Elastic. I mean, these companies, they are concerned about the hyperscalers, making huge amounts of money, right? And that's why they've kind of changed their license. I mean, if you look at, I read, I think it was a Gartner report from last year. RDS does about, I don't know, $7 billion for AWS. Aurora does $4 billion.
Mm-hmm.
Now, if the database market is $100 billion, that's a tenth of the industry, of the database industry running on, Aurora and RDS, right? That's crazy, right? So,
that's crazy.
So I can understand that, all these other database vendors, they've kind of, they've kind of spent a lot of time developing the software. They want to, make money out of it. But, if the hyperscalers are the ones doing all the monetization, then it's a problem. So yes, they've changed the licensing, and that's been that. But anyway, coming back to us, so you can, automate pretty much most of the most common open source databases, and also SQL Server. We don't do Oracle, I will say yet, because Oracle customers we've seen, they have their own bubble in a way. They have all the tools, but we're not against adding that in the future.
No, and again, I would say you all fill a gap for us, as in the OpenStack community. But I think you're dead on being able to help people run those databases at scale and have options compared to, no, I've just got to go to a hyperscaler, mega cloud, I like calling them. And honestly, like, I know we don't have probably the time to get into the business source license there, which I still, honestly, myself, I'm learning, and I'm trying to use some of the things that have been happening lately to get my own position on it. But to be honest, like the Redis change, I thought, and the Linux Foundation's involvement with GCP and AWS, essentially immediately forking and spawning this val key, that to me doesn't feel right. To have the Linux Foundation, what feels like you're working for GCP and AWS, I'm kind of like, wait a minute, what's going on? I'll also put out there, like, I don't think I'm familiar enough with I think you used a little bit different phrase, so maybe you could explain to me, but the business source license, just being able to make sure I even understand, maybe the changes versus open source. But I would also say, like, if you don't have viable business models for these great software company and engineers and passionate people about these things, if you don't have good business models, you're not going to have good products, right? Like, so there has to be a place in there for solid business models that encourages this type of stuff to be built and to be open source, and to be available for people to build upon and just grab and learn and, and make a life out of it because it was something easy they could grab and learn. I don't know. I don't have a view of that, and maybe someday we could chat again on that type of thing, because I think you're probably very familiar, especially coming from the database world.
And I think the main change has been with the there's the business source license, there's the SSPL from MongoDB. The problem is you're forbidding a category of users from basically using it. And you can't do that if you're open source. You can't say this category, you don't get these rights. I think you have rights according to open source, and these rights are universal, right? And that's kind of the problem. But I think from the other, from the database companies, typically, venture funded, well, they got to make money, they got to monetize, right? And so from that perspective, it's like, okay, if you're going to offer this as a service, then you got to have, you got to open source your whole backend pretty much according to the SSPL, right? So Amazon will have to, basically open source their whole automation magic, cloud automation magic, right? Which they ain't gonna do.
Yeah, got it. Right. Open source the skin that they've put on all the other open source that they're using. And again, in many cases, these companies are also great for some of the open source work that they do, of course, right? And I think there's good, rich history in many of these. I mean, Red Hat took a lot of heat lately for switching out CentOS and making it just more complicated for people to use CentOS. But they're still also at their roots. Many of them do wonderful things in the open source world. And so there's so much nuance in there. But I would also say it does feel like there should be some changes, because again, if whatever the system is created, where, like you said, the open source kind of fundamental is anybody can use it for anything. But but in a practical sense, if what happened is one organization who is, or three, that is massive and dominant, has now kind of carved out and started making their own rules around it, and then it used the Linux Foundation as part of that approach. Yeah, then you got to kind of go, well, is that working the right way? And so maybe there does need to be some changes to how kind of open source views it. Again, for me, I think I try to just use these things to challenge myself to go like, okay, wait a sec, because I'm a pretty open source person where I'm like, yep, put it out there. Somebody takes it, and hopefully they do good work with it. And that a lot of times the open source people understand that you have to give back. At least if you're not going to work on it and give back, maybe figure out how to buy a support contract from them. Even if your team is super good at it already, that's fine. Buy something from them because it encourages their business model. But that's easy to say as a relatively small organization compared to somebody like these big hyperscalers, where, that kind of culture can be lost. If they have that attitude, then they would immediately, my understanding, I think, is, didn't Microsoft and Azure license Redis? They actually got on board with it? Yeah. So maybe that's the philosophy, is someone at the top said, you know what? Maybe they got infected, I guess you could say, by the GitHub world, right? Where they're like, no, you need to be more open source. And maybe Microsoft takes that more seriously, and it's maybe more in their culture, which is just a bizarre thing for me to say out loud, right? I realize that as I'm saying it. But that maybe they have gotten that in their culture, and they said, you know what, let's just do business with them. And yes, I get we're going to have to give 100 million of our 7 billion or whatever you said they were making off of some of those databases. We might have to give 100 million of that to another company. Oh no. So, all right. Yeah. Sorry. I've sidetracked us. Whatever. Yeah. I've sidetracked us. Yeah. So Vinay, what other things do we want to get into today?
I want to talk about mind shift. I mean, all this to say that, cloud is no longer, right, a destination, but it's an operating model, right? But what are the implications, right? For that shift in mindset, right? I mean, for me, a cloud operating model implies that I would want to use the same automation, right, in my data center as well as in other environments, right? Whether it be public cloud, private managed cloud, right? For instance, maybe use technologies like OpenStack, like Kubernetes, right? Because these technologies would support a shift in that mindset, right? Cloud as a destination, cloud as an operating model. What's your take on that mindset shift from enterprises?
I think it's here, and I think it's here because years ago, some of the developers said, we want to be API first. Our applications are going to be API first, and that philosophy, I'm 100% in that camp. Is that these systems, they're behind the scenes, they can be many things, and they can be running and doing their own approach or philosophy. But in the front, there's an API presented, and people have followed so many standards in a great way that the API is there, which allows things like, so Terraform, for example, can be used to automate infrastructure on pretty much any provider that's out there, including OpenStack. And so with a few basic changes, you can take a infrastructure that's been built on Cloud A and replicate it over on OpenStack with some basic Terraform changes. And so that's really powerful, but that's born out of that Terraform knows how to talk to APIs, knows how to automate things. And it's just as simple as, little infrastructure as code on location A, B, and C actually represents itself to the developer or to whoever's kind of designing the infrastructure in a very familiar fashion with very little changes. Behind the scenes, maybe where OpenStack is great with using Open vSwitch, like a highly automated virtual networking system. This is actually in use all over the place. I don't know, honestly, what's exactly behind some of AWS's stuff, but I would suspect it's Open vSwitch, or OVN is also the other one. But of course, then you've now put a layer on top of it, but then you've now presented it with an API. So as long as the APIs are consistent, people continue to publish and follow that pattern, which I think everybody's in that boat. I would say we're in that direction where it'll become easier and easier to move around from different providers. And it will also enable smaller providers to not have to invent the wheel when they're doing that. Is that we can just rely on something like Terraform or OpenTofu. Now, it's hard to keep track of all this stuff that's happening, honestly, right now. That as long as you take a little bit of time yourself for the modifications that you've made specific to you, is to submit like a pull request so that your stuff can be automated by the common tools. Ansible, another one. I mentioned Red Hat before. I think Red Hat's done a brilliant job with Ansible. And having that out there as a core open source infrastructure tool is really valuable for everybody. But same thing is like, you can just release, as a company, we can release a little bit of guidance on how you can automate against our stuff. Ansible not necessarily API first versus like Terraform is, but yeah, I think that's I would fall in the camp that I think we're in a good direction here. But then it does mean that providers really do have to work out what's behind their API. But also to just remember, don't forget, it's going to have to be accessed through an API. So sometimes hardware automation, people kind of forget that, no, actually, you're going to have to provide an API to that.
Yeah. I mean, I think that requires a bit of engineering thinking. I mean, I remember back in the days, people would say use ODBC or JDBC when you're talking to a database, because it's the franca lingua, right, of databases, right? You use one API to talk to multiple databases, then it's easy to switch, right? And it's kind of, I guess, maybe, I don't know if the younger generation, they don't have that memory, right? Because some of them are born in the cloud and they don't understand what's gone on maybe before, right? When you're new in the industry, and then you see Amazon and AWS, and that's the world, right? I think I was reading somewhere that like a network engineer who knows Amazon's networking maybe will earn more than a network engineer who knows networking and can build you a network in any data center.
Interesting. Yes. Yeah.
So Todd, look, thinking, coming back to sort of OpenStack a little bit, right? As a provider based on that technology, right? Can you enumerate on the benefits an organization would get from basing their infrastructure on OpenStack?
Yeah. So for us, we're both, of course, in like an automated OpenStack as a service provider, but also a bare metal provider. And we also do large storage clusters based on a technology called Ceph. And so actually what we've found is that it's a blend that people are getting from us, that companies are getting from us. Because so sometimes big data doesn't really need to exist inside of a cloud. It loves hardware itself. Most of the big data systems were born kind of prior or alongside of the transition to the cloud. And so they actually have great hardware management systems themselves, and they have their redundancies, and they know how to use the hardware directly. So in some cases, we try, you don't want to get into the way with a cloud for that. And so sometimes the customer's like, cool. We work with a great company that's public on our site, hunt.io. They have these huge ClickHouse clusters. Let ClickHouse do its thing on these directly on the hardware. But for automation, it really becomes like, okay, actually, ClickHouse, for example, likes to use object storage as a backend for its less than hot data. Oh, yeah, guess what? We have giant object storage clusters. You can just spin those up and start using those object storage clusters. But for us, I think so. It's both the philosophy that we've carried in, which is like cloud is not a destination, but it does set expectations from users, particularly when they're coming from a mega cloud. And so you need to, I think, advice for providers that are out there is you need to conform with that. You can't make it hard for people to buy from you. For example, if they're like, hey, I need to use some object storage, they're used to spinning up some code and calling a bucket and putting some information up there. So you do need to be very familiar to them that way. Now, you don't have to do it like instantly, but you need to be nearly so, because a developer who is like, or an engineer or something who's like, I'm on a mission right now. I want to get this piece done. I've got to expand this cluster. I need this additional resources, or something's too slow. I need to horizontally scale this. You do need to respect that cloud is now a mental expectation for how your system is going to work. And I would say that's something that we ourselves are learning every day, honestly, is like to say, like, how can we conform most predictably to this expectation? And again, you want to, part of the cloud is like, let's say I'm a CTO at a company. I want to speed up my team, right? I want to empower them. I want to give them access to this stuff. Now, I'm also a good CTO and I want to be friends with the CFO, which means like, you can't blow your budgets. You can't just give so much authority that accidents happen in a way that's really negative. So for us, we're constantly balancing, we need to have fixed cost products so that the companies can be innovative and not accidentally damage themselves, hurt themselves with this stuff. But you have to figure out how to meet the expectation of a cloud native user, which is going to want to just hit some buttons and have resources available to them, or grab an API key and just start using things. And so that's very much what we're doing. And I can't say that we're perfect at it by any stretch, but this is a philosophy that we prescribe to. So bare metal, how quickly is the bare metal going to come online? Cloud init needs to run to load up whatever somebody is expecting to have on there. And then we also need to provide a suite of the most commonly needed things to do so that somebody doesn't have to kind of invent that themselves or reinvent that themselves. And so a lot of our engineers spend time on how can we make the standard use cases meet a cloud native user's expectations. That's a pretty hard thing. And so in a good way, cloud is not a destination, but when you prescribe to that, you then have to say most common use cases should have very straightforward ways of doing it, great documentation. If they're going to be following something, this users may be following something for the first time, it needs to be very good documentation. And it needs to be, a very relatively short time between the idea of doing it and actually executing it. So yeah, it's a heck of a challenge for us. So I'd have to say we face it every day, because then somebody comes in with something new and we're like, oh boy, we hadn't thought of that. Okay, and then let's get on that. Let's automate that, make it easier.
In a way, that's the promise of, OpenStack, right? As an enterprise, you want to be able to, create your own cloud and have access to all these, as you mentioned, cloud native, sort of functionality, right? But that that flexibility, it also makes it complex, right? You mentioned, you guys are really trying to automate all these things so that to give, your customer the perfect experience, right? But it's tough, right? It's complex to manage. It's complex to use, to upgrade. I don't know if it's historical, but, all these common issues that users still run into, right? When building and running, their own cloud using OpenStack.
Yeah, I would say, so if you are going to engineer, design, create your first OpenStack, your own OpenStack for a large scale production use, that is by far the hardest part compared to running the OpenStack. Running a well-built OpenStack is, you need very few resources to do so. Like, you don't spend a lot of your system administration operations people's time on running a well-designed OpenStack. But a well-designed OpenStack, building it for the first time is very difficult. And for us, this is what we took out of the mix. Ours is an automated deployment, 45 seconds. You can hit the button and you have a 3-server OpenStack backed by SEP with the object storage, the block storage, and even file system storage ready to go. You can immediately log into it, spin up a project. A project is analogous to a virtual private cloud. You can spin up your virtual private cloud. You can make your routers, make your networks, put your VMs on there. By the way, I would, of course, recommend you doing this with Terraform. And you can just hit your Terraform button there and it'll spin all those networks up. It'll spin up the security groups, the firewall. It'll do all those things for you. That part, again, once it's built and it's like a well-running system, OpenStack is brilliant. Making it for the first time, I always tell people, don't do that. Go to a professional, go to somebody like us, there's some great providers out there that can get you from zero to like a properly engineered OpenStack in a relatively short period of time. We're still kind of the only like OpenStack on demand company, I think, that's out there, but there's great providers and the ecosystem is really strong. But don't try to go from zero to a well-designed OpenStack yourself. It's really actually quite difficult. But running a well-built one is not difficult at all. And then you'd ask about like for upgrades now. We use something called Kala Ansible, and Kala Ansible is a containerized control plane. And so when you're running like a VM, that's going to be running in the traditional way as a KVM. It's down to the hardware virtualization. There's nothing in between that. But when you're running things like the routers and the switches, those are going to be now in a container running on various members of your nodes inside of your OpenStack cluster. And it's actually become much easier now to upgrade because we've taken advantage, the OpenStack ecosystem, again, the Kala Ansible team is a brilliant team, has taken advantage of all this kind of containerization move to make these upgrades much, much easier. So yeah, I would say like it used to be, upgrades used to be like an 8 out of 10 on the difficulty, 8 out of 10 being bad. And it's now down in like the 3 or even 2 range. And then like for us, what we do is before we release the upgrades, we're running them and validating them on our own test systems, then we run our own production systems on our own platform, then we run them on our own production systems, and then we use a set of very close customers to then decide, okay, how is this going to go for the customers before we release it for the general customer base. And then so the general customer base is using a vetted upgrade process. So it's just not anywhere near as hard as it used to be. But if you're running on an old one, you don't have the luxury of that kind of move. It's quite difficult to get up there. So we're running Bobcat, which is quite a recent one, and it's great. But if you have to go from like Rocky, a lot of people got kind of stuck on Rocky. That's a version from, to be honest, I'm not sure how long ago, quite a long time ago. And it is a heavy lift to get off of the older style onto the newer style. But once you're on the newer style, it's really nicely done. I definitely open infrastructure, the Open Infrastructure Foundation. I think they've done a great job with where they've landed with the releases and how it's being done. So definitely compliments to them, and it's a lot easier process.
Yeah. I think I remember being in the early OpenStack conferences, and that was the thing. Upgrades common. Very often you would have upgrades, and also it's a big project. It's a lot of things, there are a lot of components. What do I use? Which one will stick around in 2-3 years, right? These are the things. But I guess I guess the industry has had time to mature. That's
Very
now
much.
we
Yeah.
have OpenStack, which is kind of maturing, and it's used in production by a lot of businesses, a lot of telcos. What about Kubernetes? Is it a viable alternative to OpenStack?
So for us, for Kubernetes, we support kind of the popular ways of doing Kubernetes, so the ones that you might expect. But then also inside of OpenStack, Kubernetes is also supported with something called Magnum. And so Magnum is an OpenStack specific Kubernetes orchestration system. And so, but you would use it the same way. Once it's if you were a public cloud provider, let's say, you can have Kubernetes clusters spun up on demand based on OpenStack. So that's one route, of course, that customers can go. They can just use the native Magnum. But if they have their own flavors that they love, you can actually, like with us, you can do it kind of two ways. But with OpenStack, you can, of course, just spin up containers inside of VMs. So it's a common thing to just say, give me server, and server in this case is just a VM. And then then any of the orchestration systems can just simply, again, API first. This is a core tenet of this whole system. They can just then automatically place their various different resources, containers, all the way up to whatever pods, et cetera, they need to be doing. And then you can also use stateful storage available through the API also from OpenStack. So you can do it within an OpenStack. But then interestingly, I'll follow this one to the very other extreme. OpenShift is an example, is one of the Kubernetes automation flavors. I'm not sure if that's the right term for it or not, but they also offer, of course, OpenShift can natively use OpenStack and at the VM level, but it can also, in kind of an interesting way, natively use OpenStack at the hardware level. And so I was just watching a recent OpenShift discussion, and inside of that, the team was talking about, hey, we actually run a lot of our Kubernetes on bare metal. And so you kind of go, oh, well, interesting. So you are automating the bare metal. And of course, about halfway through kind of the discussion, the term ironic came up. And ironic is part of OpenStack, but it's the more fundamental part of OpenStack that's typically used to automate at the data center level. And this is at the bare metal automation. So actually underneath OpenShift's bare metal installation supporting Kubernetes is actually OpenStack Ironic. And so OpenStack is mature, it is here to stay. And it's also one of those things that's like, build on it. Like when I first started watching the thing, I'm like, I'm pretty sure it's going to be underneath OpenStack, but I was just waiting to be sure, because what you don't want is people reinventing the wheel. This has been solved with at the hardware level, and Ironic is a brilliant and mature and stable system that the hardware vendors are very familiar with, and they know that, hey, look, I need to make sure that my systems are going to follow the standards, the open source standards that we have set at the hardware level, because other software depends on that being a standard, and Ironic is a big one of them, so that it can consume the hardware properly, IPMI and all these kinds of things properly. So yeah, Redfish and all these things are kind of in the mix. So I'm not as good at the most fundamental hardware level. I definitely kind of trust my team in the Ironic team that and Ironic, of course, is what we use to be able to solve these. But I would also say is like, it is a great system. It's been out there for a long time. And again, it's in use for things all the way from, I'm going to run my Kubernetes on bare metal. Well, guess what? You're actually using OpenStack underneath. So yeah, I think OpenStack, I'm very excited about how mature it is. There's more and more additions to it, but it is also like a lot of times just remember to go and look at OpenStack. I think for the general population, OpenStack, people wouldn't think of that as like a common household name. But if you're in the infrastructure business, it is a vibrant and growing and successful software system backed by a great team at OpenInfra with a lot of things that are there. Now, maybe the documentation could be a little bit better. I'll always throw that out there. But the capabilities are really, really strong nowadays.
Yeah. Switching gear a little bit, productizing open source, right, through SaaSification, it comes with trade-offs, right? I mean, for example, for databases, right, we've been talking about workload access. Like, for example, if I have an RDS service, I don't have root access to the database server, right? I can just access the database, APIs to do queries and things. but it means, I can't do much if the thing is down. I can log into the machine, check what's going on. I have to call, AWS support, right? So that's a trade-off. The other trade-off is, there is, let's say, portability issues, right? RDS runs only on AWS. So if you want to go move it over to some OpenStack-based cloud provider, you won't get that, right? So for those who are over the fence over implementing let's say, a private cloud model, right, versus the hyperscaler route, what considerations should they make for IaaS?
Yeah, I think so. For a lot of the common things in that you're using, and again, a lot of this is driven by cost, is they're going to be very, very similar. So, right, using a VM there, using a VM, kind of any solid cloud system, OpenStack being it one of them, is not too different. And I think I'd have to defer to you all, I think, when it comes to the databases, because I know many times the RDS or something like that is going to be advertised as, compatible with such and such. And they do that, of course, for ease of moving in. But you can also say, as long as you don't start getting into their specific things that are not no longer, Postgres compatible or whatever, is that you can also be portable out. Now, but again, I think I would turn to you, Vinay, and your team and companies like yours to say, like, this is how you would actually navigate that. But I would also say, I think I mentioned this before, for OpenStack, the database as a service, the orchestration system is fine, but expertise at the database level is not as strong inside of OpenStack. So in a good way, I think you all help solve that for companies.
Yeah. Well, it's probably, my guess is, it's a bit harder for the database layer, but on the VM layer or IaaS, it's maybe more portable. So let's say an organization decides to go with a pure IaaS model, right? And I guess the everyday operational experience, would that differ between an OpenStack-based cloud and a hyperscaler? Or is there even a difference, right? As you say, if you stick to the, to the basic constructs, let's say.
Yeah, well, there are some things. So, like you had mentioned, of course, when you have your own cloud and essentially you're at a more fundamental level, you can make modifications to that cloud based upon the workload that you're going to be running. I'll use a very obvious one is development workloads that, let's say, need, just for ease, I'm going to say 99.9% uptime. They need to be available and fast for when the developer's using them and they're running systems through their pipeline. But it doesn't need to be production grade. But when you buy something on the public cloud, you're basically buying one type, right? Which is, it's got to be production grade because that's the highest level that it's going to be used for. And so one of the easy examples, and we see this with companies that come into us first with production, with development workloads, they're like, hey, I'm trying to get away from this real big expense. And one of the first things we say is like, okay, your data, does it need to be on like this super highly available, absolutely totally redundant and spread across everywhere? And the basic answer is like, no, because that's actually a copy of the production data. And so if we ever really had a terrible disaster, we would just pull the production stuff back down again. Like we have a copy already. And so don't make a copy. Like, so our block storage, for example, you can do it in triplicate. If it's like super important, you can do it in duplicate. If it's less so, you can do it in erasure coding if you need to be super efficient, and you don't mind a little bit of the speed penalty of erasure coding. But there are very distinct differences in cost because, triplicate, well, guess what? One usable drive amount requires 3 drives to do so. Duplicate only requires 2. Guess what? You just save 50%. Sorry, not the 33% inside of that. And so, so sometimes what we have is when companies are like, hey, this is going to be a big development system, please give me the kind of the lowest cost storage that we can do, that we trust at this level. It's like, cool, we'll turn down the system from triplicate to duplicate, and there you go. You've got a bunch more storage space. Go ahead, go for it. Yeah, and so at the most fundamental, I'll include this one other point about kind of public cloud versus private cloud. most typically inside of a VM, workloads are going to be using somewhere around, on average, let's say 30%. This is on average after you go over a full day's worth of utilization, or maybe longer time period. But and so it'll go like, and then you'll say, you know what, this is how much I'm actually using is 30%. But I need to have a 16 gig 8 vCPU VM because certain times of the day or certain operations, backups or whatever at night, it's going to spike up and it's going to use all 16 gigs and 8 vCPUs. And so you're going to have to buy an 8 vCPU, 16 gig VM. And then on a public cloud, that's the price you pay, even though on average, you're only using about 30% of the VM's resources over a time period. Well, on a private cloud, you own the hardware underneath. So you can provision that 16 gig 8 vCPU, and you can acknowledge that actually certain times it's going to spike, but I'm going to use that 30%. But for all other times, that other 70% is being returned to the cloud operator. Well, in the public cloud, of course, that 70% is returned to the cloud operator, and they take it and they sell it again. Of course, that's what they would do. In your case, you own this cloud. This 70% is returned to you for your other VMs. So people will say like, oh, this is an oversubscription model. You're going to oversubscribe your resources. And it's the wrong way to think about it. This is an efficiency game. If that resources, that 70% is going to be sitting there doing nothing, I'm kind of a green thinking person. You owe it to yourself to use that 70% instead of going and buying another box to run a bunch of VMs that are only running at 30%. So this terminology, people kind of use this like, oh, it's oversubscribed. No, look, this is an efficiency metric. You can use that other 70% yourself for your other VMs, which means go ahead and spin up a bunch of those 16 gig 8 vCPUs. Go for it. In fact, you could kind of spin up 3 of them, and they're only at any given time going to be using that 30% themselves. Now, you do need a certain scale to make that true. And so sometimes workloads, you have to be sensitive to your workloads and saying like, oh, well, actually, I'm going to be running a bunch of math models all at exactly the same time because that's when the staff comes in and they're going to run their simulations. That's one of those cases where no, like for 4 hours, it's going to want 100% of its resources. So you need to be wise to that. And that's why, so sometimes for private clouds, the tipping point really does become important because you do need a large enough set of workloads to be able to take advantage of that. But again, we talk to the customers when they're coming in to tell them like, okay, if this is your type of workload, we can tell you like very quickly to go like, you know what, you can actually put 15 of those on there when you thought you could only put 5. And you can actually just grab stats. Most companies will typically have some kind of monitoring system that's telling them inside of their servers, inside of their VMs, what's actually happening. And then it's pretty easy to go like, yeah, you're way overpaying because you're only using 30% of it on average, which is a pretty kind of typical average. So that is one way that definitely companies save is like, instead of that 70% going back to your mega cloud there and them selling it to somebody else, it comes back to you and you use it how you want to see.
Yes. So let's move on to environments, Todd. I mean, we know about public cloud.
Okay. Yeah.
We know about, on-prem data centers that, an enterprise may own. And what are the other models in between, right? There's co-location, there's, a managed service provider. I mean, can you walk us through, all these different environments that, sort of people have today, right?
Oh, yeah. So like options, cloud deployment models, I think we were talking about is that what are the different ways that you can get cloud? Again, accepting that everybody really does need to be cloud native. We've gone there. It's you want to stay there. Yeah. So of course, at its most fundamental level, you can build your data center. You can figure out your power, figure out your floor weight factors. You can figure out all the things that are necessary to actually construct a data center safely, get your connectivity, get your redundant A and B feed from your local utilities. That's at its most fundamental level. Then you go up to co-location, where of course you're working with somebody who's already done all the data center work, and you're going to lease a cage from them and have your 16 racks or something like that in there. There's smaller ones where you don't see it quite as much anymore, but like where you can buy a half a cab or you can buy a cab in there. But co-location, of course, would be one step up from kind of the on-premise do-it-yourself data center. Then you get into the automated bare metal world. And the automated bare metal world is I think if you were to look out there and talk to the analysts, automated bare metal is really climbing. And it's essentially, I can get my hardware quickly and easily with like really robust networking, really solid automation, and it's like kind of like they call it bare metal cloud. You'll hear people use this terminology. And then I get my bare metal and I get my access to the box, kind of as if I was in front of it, and off I go. So I don't, in the co-location space, of course, after you get your co-lo agreement with your data center provider, then you got to get your gear in, you got to get your network in, you got to figure out who's going to be your connectivity providers, you got to get your DDoS protection, et cetera. And that's a lot of work, right? Like and a lot of time typically. And so the bare metal providers have kind of stepped in there, or we're one of those, has stepped into there to say like, hey, you can now just get this hardware on demand, and then you do what you want with it. And then so in the bare metal world, it's typically you're not providing too much application level. You don't, and in many cases, you may not even know, of course, what the customer is doing with it. They're just using it directly. And then one level above that is now this on-demand private cloud. And essentially, because many times what people are actually doing with the bare metal is they're virtualizing it. They're turning it into a system that they can actually talk to through the normal APIs, right? And so they're figuring out, everything from Proxmox. You hear people go like, I got to figure out how to get a cloud now. Proxmox is kind of like a born from the home lab, a great system, but born from the home lab cloud system. But people are starting to now use it in the data center because that maybe they were familiar with it with their home labs. So the private cloud is now a more common place to go, and then it's getting more and more automated. Now with the VMware shakeup, because they were one of the players inside of this, like get my own cloud. With the VMware shakeup, it's a little bit hard to tell also what they're doing, because they shook it up and then they took back. They're like, okay, all the small providers, you're out of here. And they seem to be stepping back from that a little bit to try to help smaller providers. And small in their case is quite large, I think. So there is this whole world of hosted private cloud that fits in between the bare metal and then essentially the public cloud providers. And I would tend to put the mega cloud providers maybe a little bit different in a different scale than regular public cloud, than some of the other smaller public cloud providers. So there's the models now, though, with the introduction of the bare metal cloud providers, this automated hardware with like really, really solid networking, and the hosted private cloud. Those are really kind of the two new ones that people really need to be aware of. Now, I think a lot of people are getting that idea to say like, I don't have to do colo. I can just get this hosted private cloud or this bare metal system. And you'll also see some of the co-location providers are now offering this themselves. They have clearly read the signals on the wall to say like, hey, cloud native, I need to make my co-location product more accessible. So they're stepping into the bare metal cloud world too.
Yeah. So, and looking at the enterprise, right, from an enterprise perspective, enterprises will use multiple environments. Right? There's no one enterprise that just does on-prem or that just does one way, right? So there might be a mix of, own data centers, one or more public clouds. And if I want to extend, my operations across environments, right? So hybrid bare metal, public IaaS one, right? Now, what are the challenges and opportunities of creating this let's say, super cloud?
All right. I like it. The super cloud. You'll hear people talk about kind of hybrid or multi-cloud when they're, often trying to decide where workloads are kind of best fit. What I think in a nice way, most cloud systems have this situation in mind. And so even at the virtual private cloud level, OpenStack is like this. And depending on the OpenStack you roll, we do roll OpenStack in this way, is you go into your virtual private cloud and there's VPN as a service, which is a point-to-point VPN that lets groups at the virtual private cloud level decide what are they going to be connected to. So that's part of it. It's like you can say, I can make sure that my environments that need to talk to each other do so trivially over a safe connection. And so that's kind of like one of the fundamental building blocks. All these cross connects, like I had mentioned before, are in place. So if you're actually moving data back and forth, in many cases, if you choose like a location that's in the East Coast, it's often in literally in Ashburn, Virginia. Like this is a giant suite of data centers. There must be hundreds of them, all within like a 10 square mile spot. And so some of the times the location has been solved a bit for you based upon the regions that you're choosing. Introducing different workloads, you really want to look and say, what kind of performance do I need? What's the cost that I'm able to afford with this? Or, and then how am I going to take advantage of the scale as it goes up? And so I would say a lot of companies, we got a customer recently that they came to us because they were already a hybrid enterprise type business. And they had data center space, and they had public cloud space, and they had a lot of providers actually in the mix. But the one of the heads of sales came to us, and it was because as a company, the CEO from down had already set the policy, like, you cannot put it on public cloud anymore. We're not making enough money there. We're in some cases losing money. So the director of sales there couldn't close the deal because their data center was also full. So their colo space had already been filled up, and they didn't have resources to do it. And already the company mantra had been like, you can't put it on a non-profitable infrastructure, so you cannot put it on the public cloud. So they came to us and just said, like, I don't have colo space. You guys do the same stuff that we do. They're big into the automated infrastructure and their own cloud systems running in the colo. And so the business came to us simply because they were already familiar with this multi-cloud concept, but they needed somebody that was closer to being cloud native. Like, I need to make the deal today, which means I need to spin up the hardware tomorrow. But I can't in my colo. I think there's going to be kind of all these challenges, I guess. But definitely the CTOs and the CFOs have recognized you need to have options. You need to understand what your options are. So for us, I think it's a big part of this is being out there, explaining to people these different cloud deployment models that are available, and having, for me, I'm excited because I think OpenStack is seeing this public-facing resurgence because of what VMware did, what the public cloud pricing and cost models are creating, and people are recognizing that there is an open source solution to this, and you can go back to your roots. And a lot of the buyers that we see, they want to go to their roots on this. They grew up being an open source person, and they would like to be closer to the technology again. So I think for us, it's exciting to see that, like, people are recognizing, oh yeah, there's great open source solutions for this, and I get to go back to that. I get to feel good about that.
But that's interesting. I mean, but open source cloud, right? I mean, what does the future of that look like? Because I think one key thing you mentioned earlier was, if you're running the old OpenStack, that's going to be tough. It's harder. The new one is, more packaging, more automation. It's easy to, kind of run, so to speak, right? If you know how to put it together, maybe work with some experts there in the field like yourselves. Will we see more people shifting over, right? Diversifying their operational model, right? Thanks to open source. How do you see, this going, especially in the light of, Broadcom, right? You talked about that as well with, the change of, I think the whole VCPP program was canceled, right? So quite a few number of our, prospects, they have been mentioning that they are starting to search for alternatives, right? Because VMware was in pretty much every single data center, out there. They've been so big. So what are the implications? Will we see more consideration for open source cloud software like OpenStack?
This is the live situation now, then the answer is absolutely. Yeah, it's happening already. So this was, OpenStack has always been backed by some of like the greatest efficiency companies out there. Walmart, for example, right? Big OpenStack fan and runs huge OpenStack infrastructure. So you have somebody like that who is like, we care deeply about cost. And of course, they're going to do it themselves because they have the scale. And at the fundamental, of course, it's a better way to do it when you have the commitment, I guess, to excellence like they do, cost-wise excellence. And so, yeah, the systems are absolutely stable and have been growing themselves behind the scenes, you could say, from the consumer's viewpoint, from like kind of a household consumer viewpoint. It's always been growing, and more cores, more and more infrastructure being run with it. But now OpenStack is coming back into the smaller and medium-sized businesses' views because they need an alternative now to something like VMware. And yeah, absolutely, we're getting those exits onto OpenStack. You can see companies like there's Hystacks and Storeware and Trilio, who actually is a new partner of ours, who facilitate easy transfers like virtual to virtual cloud environments to facilitate people moving out of VMware now. And it's just simply because in many cases they're required. They're like, you lost your ability to run our license, so you need to get out. Which is really, again, I don't think that move was quite executed the way that you think it would be. I get what they're doing. They're like, we need to raise the revenue, so we're going to do that. And 100% they're going to do that. Broadcom, that is. But yeah, so I would say that it's a live situation. OpenStack is ready to help VMware users go on and continue having successful MSP companies, and SaaS, if they're a SaaS running on there. OpenStack is ready to help with that. And there's, like I mentioned, Trilio and Hystacks and Storeware and companies like this are ready to help people move into clouds like ours.
Now, is there like a next, unlock, right, for these open source based clouds, right, to even increase even more the adoption? Like, do we need somehow to provide more than just IaaS, right? So, maybe platform as a service on top of that to make it easier for organizations, or maybe some kind of workload specialization. I think you mentioned, in some cases, you don't want to have something in between, right, between the application and the actual bare metal. You want to go more direct. So where do you see the next unlock is, when it comes to these open source, clouds?
Interesting. I think, you do see in our space, there's more, OpenStack and typically Ceph-based clouds, they're getting easier and faster to deploy. So I think more and more of that will continue to occur as they get richer with features. So like today, I picked on database as a service is something OpenStack needs more you guys inside of to help, make that have closer parity with some of the other providers. There's a few other things that are inside of there that, so like native security applications, so like for us, we have to leverage in some external open source ones, but some external ones to help our customers, because OpenStack itself doesn't have like a security center as some of these other providers would have. They don't have as natively a transfer and migration center. Like if you were to look in some of these other big providers, you're going to see these systems like be really natively integrated. So I think that's the next step, is for the community to now recognize that this is happening, and for the community providers that do those, they have to get in there. They've got to get with us and with other providers like us to say like, hey, you guys are selling this stuff. How do we help you fill these gaps? Like for me, we don't want to do everything, and honestly, we can't go head to head with AWS. Like, come on, like that's just not the thing. We have to do it as a community, as an open source community. As an open source community, 100%, we have a dominant share of the world, but we just do need to come together as a group and have some of these platforms that we get behind. We're hopeful. We have our community system. We're hopeful that people do that with us, because we can automate. We're a fundamental, long time in data centers. We know how to get hardware where it's supposed to be at the time it's supposed to be at, and so that it's like invisible to users of the cloud systems. But we're not experts in database as a service. We're not experts in this migration as a service. We're not experts in all these areas, and we really want to have a group come together to help us have this parity that you have to have. So I think that would be one of the big shifts, is that really, and maybe it's led by Open Infra, maybe it's led by an organization like us or something, or as a community, we just decide we're going to do this. that is one of the things. Is like, if you want to be at parity with some of these trillion or whatever they are, $1 trillion companies, you're going to have to do it as a group, as an open source, hopefully, group that accomplishes that.
Yeah. So one kind of a bit of a crazy question. I mean, it all roots back to hardware, right? At the end of the day, are there any risks, to this, let's say, ecosystem proliferation? I mean, will there be enough hardware, right, for, I don't know, 10x more providers?
You've actually kind of poked the bear with me, because even today we are struggling a bit there. And so in our case, we actually have a rolling purchase process, and we're just guessing that 6 months from now, we are going to have this demand in this area, based upon historical, but still it's a bit of a guess, which I don't like doing, because it's taking so long to get the gear in, because somewhere, some particular component is not available, and it's something you have to wait on. The box can't ship or function properly unless you have this proper thing. And so you have to fight to get in line right now. And so it's really complicated. And we prefer, we actually use this really high-end Micron 7450 Max SSD. And it's awesome. It's like the best thing you can buy. But other people know that also. So we're in a queue all the time, sometimes with our providers, to make sure that we can get a hold of the things that we believe in. That's been a pain point for us. We deal with it by, we have a great backer in this bank called Truist that helps us make sure that we can have the flow of hardware that we need in order to accomplish this. But so sometimes we're just now getting some stuff we ordered in December, and boy, it was close, so this is a bit of a trick inside of there. So the logistics associated with hardware is definitely a constant battle. And will there be enough? I mean, I think, or you've probably heard, there's a lot of investment now, both government kind of mandated and funded here in the United States, to get chips manufactured, more of the manufacturing to come back to the United States. We have TSMC even coming over here to build in order to support that. So I think everybody's aware that this is occurring. We feel the pinch, but I would also say it doesn't matter. You have to be cloud native. And as a provider, you've got to enable your cloud native expectation user to hit the button when they need it. And so we do that through all kinds of like predictive ordering, honestly. Yeah. It keeps me up at night, though, on the day. I think you're having to poke on that one where I'm like, that is an issue for us. And sometimes it's the littlest thing. You're like, this little chip on this, on the NIC card, you couldn't get it, and you're like, oh, geez, come on. Can we get a different card? No, all the cards use that Broadcom, honestly, they use that little chip, and there's something wrong with this factory. And so it's not in the pipeline. And so your box is sitting, and then the manufacturers, of course, they'll make the box and they have to pull it off and stick it somewhere for a while until that part comes in. They can stick it back in the line and finish it and send it out. So they've got all kinds of logistical problems too. Warehouses filled with 99% built boxes that are missing some little component, so. Yeah. All right. Well, I think we covered a whole bunch of stuff today, but any last stuff that we've got to get into?
I think that's it. I think, this isn't great. I think, Todd, to summarize, what would be your recommendation, to enterprises when it comes to, let's say, devising a cloud strategy?
Understand the new cloud deployment model options. And you can absolutely turn to open source, and open source has matured right along with the big mega clouds. And so your systems are available there. Look to good companies that have specialization in areas on top of the open source stuff. Yourself's a great example. And you can have cloud native infrastructure very easily from other cloud deployment models or methods. That's like, I would say the big takeaway for CTOs is that like there are options for you now, and they are fast and easy and reliable, cost predictive, all this kind of stuff. So that's what I would say in summary.
Excellent. Well, thank you, Todd.
Cool.
It's been great talking cloud and OpenStack with you, right? So that's it for today, folks. See you all for the next episode. Thanks, Todd.
Excellent. No, thank you for having me, Vinay. And again, thank you for bringing my watchers up to speed too, also on several nines. You guys got a lot of good stuff going on over there.
All right. Excellent. All right. Take care.
Cool. All right. Thanks.